similar, right? Well, apart from the fact, obviously, SAP is in sort of German and they don't let you anywhere near their data tables, but it would look like this, right? You have a fact table that has your kind of general ledger, and this will have a number of keys onto your star schema. So a general ledger system is already a star schema, so you would think it's perfect for business intelligence. One thing to bear in mind is the keys or the dimension are usually always flexible, because when someone sells an ERP, they don't know what industry the person is in. So they typically have fields like 1, key 2, 3, all the way up to key 12. And the business defines the dimensionality of the model. This was quite a shock to me to hear financial accountants actually use the word dimensions, because I was like, I thought that was kind of the I term, but actually, people that design general ledgers do use the term dimensionality and dimensions, and they define the dimensions of the general ledger. Typically, it would have like date, chart of accounts, cost center. These would all be fixed. But then you'd have a couple of variable dimensions that are industries. Product group. Things that are specific to the industry. That's kind of what. Now, your chart of accounts then is your account structure. So let's just look at what that. So that's what things are posted into. And what I've done is this model comes from AdventureWorks, right? So to start off, I'm like, well, can you all of this up direct from the kind of data model and use the wizard in Power BI, join all the tables and make a report up? That's what I've done, right? So I've taken AdventureWorks, I've done kind of a next in Power BI, and I end up with something like this, right? I'm just going to. Right, so here's Power BI. So I've literally, if you look at the tables on screen here, hopefully you can see this here. I have dragged in tables or files from kind of Power BI. I've got my general ledger table here, and you see I've got these keys that go to, now in AdventureWorks, they've got department, scenario, organization, account, and date. So it's quite unusual because usually a customer will at least have a product group in there. I suppose they've got a department, which could be the department the product came from or something like that. Channel it was sold in. What I've done is I've just done next, and I've built a hierarchy out of this. And we start to get something that almost looks like a profit and loss, because the chart of accounts in AdventureWorks has this 6 hierarchy where we can see the operating profit, gross margin, goes all the way down. There's a number of problems with this naive kind of method of just. So let's look at some of the problems that might be with this model, because so far you forward. Now, in order to build the hierarchy, see on screen here, there's this 6 kind of level hierarchy, and that 6 level hierarchy, you use various functions to make that into a to what we call naturalize that by making sort of columns, and that kind of helps us build that kind of hierarchy there, because it's actually a parent-child. If you go to the SQLDay kind of website, there is a parent-child design pattern that shows you that kind of naturalization process using the kind of DAX functions pass and path length. So that's how we've got that hierarchy with the pluses on it. Now, the basic problem with it is, okay, so the first problem that you'll notice is the fact that the profit and loss doesn't work, right? And the reason it doesn't work is if you look at the total profit at the bottom, 2.5 million, well, if the sales were 1.2 million, it couldn't possibly have a profit of 5. And the reason is it was supposed to take the sales and deduct the operating expenses, but instead it is added on. So the first problem is what we call a unary operator or a signage, that when the information comes out of the ERP, because of the way it's structured in terms of debits and credits, everything is seen as a positive, including an expense. and we kind of want the expenses to be a negative. So there's a few ways of doing this. A few people would try and do it in DAX. So you could put an if statement, say, well, if the account type is an expense account, make it a negative, right? A better thing to do is to push that down to do it during the ETL stage. So if you've got a SQL data warehouse that you're kind of loading it into as part of your ETL in your views or your stored props or whatever you're doing, you invert the kind of signage. Now, I've actually done this completely in sort of Power BI, right? So if I just click on transform data here. Right, so when I go to the account, I'm just going to go to the advanced editor, right? Show you what the, that's the naive one. I've got no calculations at all. And then what I've done is I've cleaned it up a little bit in this version here, right? When I look at the model in this version, now you could also do this using the wizard, right? But in this version, you'll see what I've done is I've just clicked on the button to create a calculated column, and then I added an if statement, say if the account type is expenditure, then multiply by -1, else 1. Right? So it's a really basic way of applying what I guess we used to call a unary operator in the MOLAP days, and what you get is the correct operating profit at the bottom now, because sales are seen as a negative, right? And this is very common, like all our ERPs would have this. So that's kind of the first thing, is sort of get all the numbers right, okay? Now, the next problem that we'll look at is the problem of I would call the ragged hierarchy. If you look at the parent-child structure that comes out, then it comes out like this. It looks pretty ugly, right? So if I share my screen and show that, share my screen, I'll go to the naive version that just comes from like a next, and you see that when I click on taxes, some of the items have 6 levels of hierarchy, but taxes only have 1. They really only register taxes. They don't have 6 kind of levels of taxes. Now they should at least 2 levels of taxes, because you'd think you'd have sort of corporation tax and VAT, right? But you know, in this example, it's only 1 level, and these pluses probably not what the accountants are. So that's one of the problems, is Power BI doesn't natively support what we call ragged hierarchies here. Now, there's a few ways of dealing with them. You can change the visualization around to kind of make it stepped, but it doesn't look very nice then, right? So the way that I tend to deal with these ragged hierarchies is like this. This model, you'll see the problem is solved. When I click on the plus, I don't see it down. And what I've done is I've changed the model slightly. If I click on the table and go to the account, you'll see I've taken as it comes. So it's a parent-child. I've added this path function to get the parent-child, and then I've split each of the levels out. So that's the naturalization process, as we call it. And then I've registered what the account depth is. So for this particular chart of accounts, how example of tax is going to be level 2, and other ones could be 3, 4, 5, and 6, right? And then there's, say, a relatively new, but it's a few years old now. There's a function in DAX called is in scope, okay? And what I can do from that, register the scope that's currently selected on the report. So this will tell me whether I'm a level 6, 5, 4, 3, or 2 as report. And I can say if the current scope that's shown is less than hierarchy is, I'm going to return a 1. Otherwise, I'm going to return a no. I'm going to multiply the figure by that. And that kind of magic is what effectively makes the hierarchy work now, so that it's no longer ragged. Now, there might be a feature improvement at a later point in time where there's a natural way of doing that, right? But so far, I'm currently using DAX to do that. And that's probably some of the only DAX that I use there, right? Now, you might not have a ragged hierarchy. It depends on your ERP, right? Pro forma layout, right? So if you look at the layout on the right-hand side, got now my naive kind of version of just bring it in has brought in the raw numbers. So I've got sales and I've got profit, but I don't have the calculated members, right? And one thing I've learned is when the financial accountants give you the format of the profit and loss, we've spent years arguing over the format and whether something goes above the line or below the line and what chart of accounts are included and what labels are included. So you as the BI consultant coming up to this finance team and telling them that you're not going to do it that way because it doesn't support the tool isn't going to fly, right? You've got to produce it exactly as they ask for it. And then after you've given them exactly what they asked, you can then work on adding visualizations. That means we have to add these calculations into the model that do these sums, roll-ups. Now, if we look at a typical one, for example, EBITDA at the bottom, right? Earnings before interest, taxation. The way the accountants think about it is, well, it's profit after tax minus interest, maybe minus tax and, well, right? But you can also represent in thinking EBITDA is really running sum of everything above the line, right? Everything below the line is not included. So all these calculations, including a subtotal, is, well, it's a running sum over a smaller item. So if we look at sales, well, that first kind of subtotal is kind of a running sum. If we look at operating expenses total, well, that's a subtotal of the previous four. So what I've developed is a way to soft code. Yeah, so there's some great questions there coming in that we'll chat afterwards. Some people, this is one of the reasons that some people will say multi-dimensional MOLAP is a little bit more featured when it comes to financial reporting, scoped assignments, native support for kind of ragged hierarchies, and roll-ups. You could kind of implement these things a little bit more, right? But for most of our projects, our customers are looking for Power BI or models. So we're not really pushing MOLAP kind of models, even if it's a little bit more work in order to get it to work. So what I've come up with is, how do we take care of these calculated members and stuff like that? Now there's two distinct ways that people do it, right? Well, sorry, there's three actually, right? One, I'm going to implement all of these as kind of measures, right? Which going to work very well because you kind of want them on the rows, right? The other is I'm going to use something like a calculation group or a switch statement to provide floating table that has all these in, but these are all different kind of. Now it usually forms like a dog if you do that, right? So the way that I'm presenting is a no DAX way of doing it, right? So it's purely handled by the kind of data model. So introducing our friend many-to-many table, right? Now I know that kind of many-to-many tables have a bad, right? The Italians are probably turning over in their grave, but bearing in mind the chart of accounts is a relatively small table. It's only generally got, you know, a couple of thousand rows in it, right? And what I'm doing, I might just share my screen and show some Excel to walk through it, because this is a point to get here, how to do calculated members by using. Right. So what I would set up is a table that I'm calling an account range or a report that is a floating table, right? It just exists outside of the ERP. And for every line on the profit and loss, I'm defining what type of operator it is. Is it a natural sum, in which case it's going to be a sum of various things that are in the RP, like a chart of accounts, running sum, or is it a custom calculation? For example, cost of sales is a custom calculation that's going to sum up these two columns here. Most of these things like EBITDA, net invoice sales can all be done by a running sum. Then for the ones that are a sum, I then have a table that defines the from and the to. So that's really what that table defines. What I'm going to do is explode this out to make a many-to-many table. So the many-to-many table, I might just... The many-to-many table will take these two tables. On the left, we've got the report lines, and on the right, we've got the ranges of which account codes make up which lines on the report. When we design that, we'll end up with this kind of data structure that sits over the chart of accounts. Have the chart of accounts many-to-many structure to this other table that's not part of the ERP, which defines the report. And this many-to-many table acts as a bridging because any line on the report could have the same element from the chart of accounts. For example, if we look at a subtotal, it's going to re-include that figure. So one of the challenges, how do we calculate this table? So as an example of how to populate it, I've got the world's most basic here on screen. The second table down is the profit and loss. So we see we have sales. We have two types of sales, and then we have expenses, and then we have profit, and two of them are running sum. Screen, we've got what the account codes are, or the chart of accounts, and what those range numbers mean. And then on the bottom part of the screen, got rules that say to make this line, it's from that range, that range. Ranges, or these general ledger codes, is the key. Accountants treat these account code ranges like network people treat IP ranges. They're like, well, this range of IPs is for this building. Accountants are like, well, this range of IPs is for sales. Much like IPs, they're never clean ranges. Well, from 1,000 to 2,000 is sales, and then they find all except for 999. So what we do in that scenario is we create two ranges or three ranges so we can define all the rules. But once we have these rules, we then explode it out into this many table. So if we start off at sales has a from and a to, 1120 to, I think. Right. So when I populate it, I see there's two account codes that match that criteria. So I put in a 11 and a 12. Then I come down to the next one, which is, next line is, trade sales. There's only one matching for trade sales. So 2 and a 3 goes up. Next item on the report 3 is a running sum. Running sum, I have to include everything on top of it. So 3 includes 1, 2, and 3. Here, that this kind of data model now gives me running sum and a base element as well, which has got some kind of roll-ups in it. I repeat that down. 4 only has one item, and 5 is the total profit that really includes everything. So 5 has 1, 2, 3, 4 in it, right? So that's the key concept there. Now, how do I make that table, right? A few options on how you make that table, right? Because it's probably not going to exist in that form within the ERP, right? I'll just show a screen. I'll show you a few ways of making that table, right? Now, one thing to bear in mind that what I show you, the PBIX is available for download. I've got a link that I'll share at the end, and it's in my deck as well. So you can actually download this and feel free to reverse engineer and see if the structures that your ERP type of structure. I had a good few people, I presented a similar talk at another conference, and guys emailed me who were using Dynamics and a few other ERPs, and they certainly managed to fit into this data model here. Show you how to calculate that many-to-many. Right, so this is the many-to-many table that we want to display that bridges between the chart of accounts and the soft-coded financial report. So there's a few ways of calculating that, right? Now you can do it in Pure DAX, right? And I will show you how to do it in Pure DAX. A lot of our systems have SQL Server underneath them, so we would kind of do it in a stored procedure, and it's much easier to do in T-SQL because the ranges are defined on a from and a to clause. Right? It's from this range of accounts to this range of accounts is sales. From this range to this range is expenses, say, right? So, I think files in the right place for this. All these files I'm using, I have put up on a GitHub. So if you just want to see the sample, you can certainly work through it there, right? Here we go, right, that's better. Okay, how do we create that many table? So what I've done is I've got this account rules table that comes direct from spreadsheet that I might get from the ERP or the accountants might give me externally. And this tells me for this line in the report, I'm going to use this range, right? So this is the basic roll-ups, right? Sums. It's not kind of running sums, right? So what I do is I take this table here, and this comes direct off the spreadsheet. And then I effectively just get it to this type of table here where I have the line on the report and the from and the to, right? So that's basic rules. On the core ones then, what I do is I take it through a process where I want to take this from and the to and explode it out. So if I look at this one, 4130 to 4139, I want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I do is using effectively Power BI, I can expand. There is an expand function where I can expand I think I've got to do it in the advanced editor, but I can expand to say expand the from and the to, and what I get then is the exploded rows. So if I just go to where I expand here, you can see I now get 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So I've taken the from and the to, and I've basically expanded them out. So I've cross-joined them. Right. I can then join it back onto chart of accounts to say, well, just give me the ones that are valid, because they might not have used 4132 yet. Right. They might have only used 4130 and 4135. So I merge back the chart of accounts in order to join that. And once I've done that, I can get to the point where I get this type of table here then, where I just say, give me the unique list of accounts that are for this line on the report. So that's the core, that's the base ones, like just roll-ups from the chart of accounts. Do the running sums then is almost identical, right? The difference on the running sum, and I just show you in the advanced editor to look at the M code, is when I expand the running sum, what I'm saying is give me all of the rows that are up until the row number that I've selected, right? So see this expanded is give me all the rows up until the child number. So what I get here, if I just step through that, starting point is this. So I only want the running sums, right? So I filter out to just give me the running sums, okay? And then what I'm going to do is for the running sums, I know the running sums, I know effectively what their report, what the line on the report is. So I'm saying for 4, give me 1, 2, 3. For 6, 1, 2, 3, 4, 5. And I'm going to use that expand function again in order to do that, right? So the expand function has expanded it to give me that 1, 2, 3, 4. And that's going to be for the 4th line of the report. Then for the custom rules, I do the exact same thing. So the end result is this table here for the running sums. For the custom roll-ups, where it's completely arbitrary, I do the exact same thing, but I use the join on the arbitrary kind of custom rules. And then I union all 1, 2, 3 of these into the final many-to-many table. Now that's doing it in DAX. I appreciate that's probably quite complex if you haven't done M before, but what you can do is you can download this workbook and you can work away on that. Now, an easier way to do it that I find is if you look at my screen here, if you're writing something like a stored procedure, it's slightly easier because it supports the between clause. So you can say, find me all the chart of accounts that are between this range for this line on the report, put this into the many-to-many table. For running sums, select all the ones where the line on the report is less than the one that I'm kind of using, and so forth. So, you know, most of our systems would do it in T-SQL because we might have a SQL data warehouse underneath it, but we can equally completely do it in Power BI as well, right? So that's the key concept, is building that many-to-many table. Now, once you've built that many-to-many table, what you then have, if I just zoom in on my report here, this concept here, where your report will now naturally include subtotals, calculations that are running sums, roll-ups. Is guess how much DAX I have to make that happen? None. It's all handled by the many-to-many relationship here. So when I'm looking at running sum, like net invoice sales, because all of these joins are repeated in the many-to-many table, it's going to naturally sum them up. And the same goes for the for like the key performance indicator, right there. So that's how we build that many-to-many table. That's the example that we kind of work through at the logical level. Now, generally need some DAX. So the benefit of this approach is there's no DAX, right? I haven't written any DAX so far unless I had the ragged hierarchy to fix, right? But you may or may not have that depending, right? Some calculations that we might have to do with is things like budgets, because they may be contained in the same table or they may be contained in a different table. If I just switch to the table view, look at the general ledger here, you'll see AdventureWorks, quite unusual, although I was chatting to someone whose ERP actually does this. AdventureWorks puts the budget in the same transaction table as the actual amounts. And there's this field called scenario that tells you whether it's the actual or the budget. Could be the forecast or the revised forecast as well, right? Most larger systems don't do this for a number of reasons. Performance being one, right? If you look at a system the size of SAP, it's never going to do that because sticking all the stuff in a single data table isn't going to give them the best performance of their SQL table when they're running, right? So they're generally going to have budget, a separate budget table. The other reason it's probably not a great idea to do this for most ERPs is generally the budget is stored at a different grain than the actual transactions, and sort of mixing items of different grain in the same table. You know, that's often seen as a no-no in a. So you might find there is an actual table, a budget table, and a forecast table. In this case, it's all combined in one. So we have to use DAX to effectively split it out, right? So let's have a look at the DAX that we might use in order to split out this scenario key here. So see the scenario key? This is going to have like actual budget forecast, right? So if I just look at my fields, see that when I look at the GL amount, probably going to see it's going to be using a switch statement based on the scenario. I'm going to filter based on the selected scenario. So I've got a disconnected slicer that gives me my scenario, and I'm going to either use all budget or forecast. So see the scenario here. I could sort of drag that on screen and say, hey, I want to see budget or forecast, and I can decide what I want to put in there. If I don't select one, I would the actual. If I look at GL budget, what I'm doing is I'm forcing a budget in the filter criteria, right? So that's not very complex, and that's how we handle when they have a scenario in the kind of general ledger, and that then kind of lets us do actual budget and calculate the variance. Now let's have a quick look at balance sheet, right? So just got a few things to look at. Balance sheet can use the exact same structures, right? It can use the kind of general ledger, but the difference is we have the concept of opening and closing balance, right? And the balance sheet report is usually based on the closing balance, right? Now, most ERPs do not do it the way that Adventure works. So in Adventure works, if you were to get the closing balance, you'd have to sum up the transactions over all time. That's what the DAX is on screen. I'll share my show you the actual Power BI kind of model. So here's the general ledger, and you have to sum up all of these kind of transactions all the time. Now, generally that is seen as an awful idea on large ERPs. The reason that's an awful idea is twofold. A, if you've got 10 years worth of data in there, having to sum up all of the data to get your sort of balance sheet is probably going to hurt you from a performance perspective. And if it hurts Power BI, it's going to hurt the sort of OLTP version of the ERP even more, right? And then two, in a lot of ERPs, history can get corrupted, right? So say, for example, they could have had a database corruption, or someone could have accidentally changed some rows from 10 years ago, right? ERPs aren't as stable as you'd hope for, right? VAs do accidentally make changes or patches. So having to have the previous 20 years of data perfect before the modern data makes any sense is a dangerous thing to do, right? So what they would generally do is have a balance table where every year or a snapshot every month, they'd say this is what the opening balance is, and the calculation would take that opening balance. But in this case, it doesn't have that. So when I go to closing balance, I'm closing balance formula to show you what this looks like. So you'll have to look at your ERP and how that, and this is a very standard pattern that you'll see on the sort of DAX pattern site or anything like that for doing closing balance. When you do that, I now have my balance sheet report here. Now have a balance sheet report here. I've got non-current assets, current assets, and I've also got a reconciliation at the bottom where it's going to sum up all these values. Because all the current assets, long-term assets are positive and the liabilities and equity is negative, it balances to 0. Okay, so that's good. Now let's One of the nice things about this design pattern of soft coding the reports into rows in the rules is you can implement report versioning, right? So if you look at the balance sheet here, right? So one of the misconceptions I had when I first started doing financial reporting is that I just think. So one of the misconceptions I had is that the entire organization had one profit and loss and everybody shared the same loss regardless of what division you're in. But as I worked on larger systems, I found there were different countries that had different regulations. There were different teams that had different perspectives. And sometimes they wanted to see a different balance sheet or a different profit and loss with different items included in it. And you weren't going to change their minds to try and get them to use standard format across the whole organization. So what we can do is when we set up the rules tables, you'll see that when I define the rules for the profit and loss, I tell it what report it's for. These are the rules, and I can also have rules in play for the balance sheet example, right? And then if I want to do a different set of rules, say for example, they made a different version of the profit and loss, I can copy that, paste it, and call it P and L2. Sorry, I just and in there. Second version of the report, and then I can change the report to say, well, no, I want to change the spelling here. I don't want that line in there. I don't want to show that running sum on the report. Then when the user is rendering the report, just see here at the top right of the screen, I've got a slicer to pick what version of the balance sheet. So here I've done a second version of the balance sheet. Same numbers, but it looks completely different because what I've done is the first version had short-term assets and long-term assets, creditors and long-term kind of liabilities. The second version is a much simpler view. It just have, here's all my fixed assets, here's all my liabilities and equity, and see that the total liability and equity equals the exact same kind of data and a user flavors of the balance sheet there. That's report versioning. And that's a useful side effect of putting all of your lines of your report in data, as you can do that type of stuff. Now, the last thing I'll show before we go to Q&A there is empowering Excel, right? One thing you can be absolutely certain of is as soon as you render this nice Power BI pro forma report that has it exactly as they want, first question that's going to come out of the lips of the financial accountant is, can I have that in Excel, right? Can I either export it to Excel or can I even better do the analysis in Excel? So once you've got the table structures like this, financial report here, many table, go into your chart of accounts, go into your general ledger. That's very easy to do, right? It's fully supported and that. So here I've got my profit and loss reports to analyze in Excel, and I'll get an empty table report up. Just wait for it to come up. Hold on, I'm not screen. I'll just start that again, right, just to show you the journey. Right here, I've got the kind of Power BI service to Excel. Now, how many drags of the mouse to get a pro forma profit and loss for a financial accountant? Here's Excel. The first thing I've got to drag on is the, I go to my general ledger and bring on the amount. So that's one drag, right? I might decide as well as the amount, I also want to see the budget and the variance as well, right? But that's, right, I might want to see the variance percent. That's my first interaction, is to really put the amount on. So that's one, right? Then I go to the financial reports, okay? I drag on the report hierarchy. mouse drag, right? And then I've got to tell it what type of report I want. So I drag this on as a slicer or a filter. I'll do it as a slicer, it doesn't really matter, right? Then that's my third interaction. Then I expand it out. What you'll see is on screen here is exactly the same as what I have on Power BI. Right, now I haven't selected a time period, so the numbers won't be exactly the same as statement is identical because it's coming from the same hierarchy, from the same structure, the same kind of numbers. Obviously, these are higher because I haven't selected a date range yet. Using this, the financial accountants can then do their analytics in Excel as well as Power BI. I could say, right, I want to see that profit and loss broken down by, say, for department. Code. Now showing the profit per department and all the charts in Excel. So with that data model, we can support both the Power BI community and also provide the exact same pro forma layout in Excel. Okay, so just to summarize, so one of the advantages, it takes a lot of learning to get used to that kind of metadata and writing that many tables and how it's done. But once you do that, you now don't have to write virtually any DAX, and that makes for a much more faster and more flexible model with the benefits of being able to do, versioning of the reports, full support. So that's kind of the secret sauce of the making of those types of financial reports is, got to soft code the report lines into play, so it gives you an example of how to do that. So we'll leave this up here. One important link here is, see the first link in GitHub. That's where you can download a copy of the PBIX and a copy of the sample files if you want to actually load the actual data that I used there. Okay, so that's about it.